So for the three last questions, problems, they're a little bit difficult because you do have to think what are they really asking you here. And so now they're asking more questions that need you to uh, figure it how you're going to do the math, and then you have to do the math. And so we have carbon 14 right here. And the questions, it's telling you that they want you to estimate the mass of one of these carbon 14 as precisely as you can from the data in the model. And the model they're talking about is the one all the way at the top. And so you need to go all the way up here. And so you can see that we have carbon 12 here, 13, and carbon 13 with one extra electron. And so you can look at AMU right here, and you could just do simple math to deduct, to find the value of one proton, one neutron, and one electron, and therefore find out what the mass of one carbon 14 would be. And so, um, doing so, you should find that uh, carbon 14 should be 14 AMU and a little bit more, because it has 14 particles in the nucleus, so it has to be at least 14 MU. And it should land somewhere around 14.006 8 AMU. And so the second question, you need to use the data model 1, which is pretty much the same thing as you did here. We need to estimate the value in MU, the mass of an electron, the mass of a proton, and the mass of the neutron. We should have already done that if you have done the problem 1 correct. And so again, just use this model to like here we got hydrogen isotope 1, and so that means it has 1 proton and 0 neutrons, while hydrogen 2 is going to have 1 proton and 1 neutron. So by taking this number, subtract this number, I should get how much 1 neutron weighs in AMU. And by doing the same thing with this number and this number, so take this number here, subtract this number here, you should get the answer of 1 electron, because the only difference between this one and this one is that this hydrogen ion has 1 electron more. So you should then find the weight for 1 electron, and that should have landed on 0.0005 AMU. An electron is very tiny. And so you're going to find that a proton is slightly less than a neutron. So a proton around 1, and neutron around 1.0035 AMU. So the last question, it seems very difficult, but it's not as difficult as you think. It tells a lot about Einstein's equations, but it essentially just wants you to do the same type of math by using the known values for how much a proton and a neutron and electrons has in mass. And if you do the same thing, the math here, you are going to find that the math equate when you do the math and how much each of these particles weigh, you're going to find 12.099 AMUs for 1 carbon.